Battery ignition system is used in automobiles to produce spark in the spark plug for the combustion of fuel in the IC engine. Here the main source for the spark generation is the battery. It is mostly used in light commercial vehicles. Almost in every petrol engine, the need of spark is required to burn the fuel in the engine. And thus an ignition system is always there in petrol or gasoline engine for the spark generation. There are different ignition systems such as a magneto-ignition system, distributorless ignition system and electronic ignition system. Here we will discuss one of the ignition system. So let's get started. Main parts. The main parts of battery ignition system are 1. Battery. 2. Ignition switch. 3. Ballast resistor. 4. Ignition coil. 5. Contact breaker. 6. Capacitor. 7. Distributor. 8. Spark plug. Let's us discuss the function of each component one by one. 1. Battery. It is a device which provides electrical energy for the ignition. The battery is charged by a dynamo driven by the engine. Generally, two types of batteries are used in spark ignition engine: lead-acid battery and alkaline battery. The lead-acid battery is used in light-duty commercial vehicles, whereas alkaline battery is used in heavy-duty commercial vehicles. 2. Ignition switch. It is a switch that is used to on or off ignition system. One end of the ignition switch is connected to the battery and the other with the primary winding through a ballast resistor. 3. Ballast resistor. It is connected in series with the primary winding. It is present in between the ignition switch and ignition coil. The function of the ballast resistor is to prevent the overheating of the primary winding of the ignition coil. How it does this? The ballast resistor is made of iron wire, and iron wire has a property that its electrical resistance increases rapidly with a small increase in temperature. If the current from the primary winding flows continuously, the temperature of the ballast resistor increases, and this increases the electrical resistance and reduces the flow of electric current through the primary winding. The reduction of current by ballast resistor prevents the overheating of the primary winding. 4. Ignition coil. It is used to produce high voltage sufficient to generate spark across the electrodes of the spark plug. It acts as a step transformer and converts a 6 or 12 V of a battery into a very high voltage of about 15,000 to 30,000 V. It consists of a soft iron core surrounded by two insulated coils, named as primary winding and secondary winding. The primary winding consists of 200-300 turns of 20-gauge wires capable of producing resistance of 1.15 ohm. The secondary winding consists of 21,000 turns of 38-40 gauge enameled wire, and it is sufficiently insulated to withstand high voltage. One end of the primary winding is connected to the battery terminal through the ballast resistor and ignition switch, and another end is connected with the contact breaker as well as the secondary winding. In the case of secondary winding, its one end is connected to the central high-tension terminal of the distributor, and other end is connected with the primary winding. 5. Contact breaker. It is a mechanical device which is used for making and breaking of the primary circuit of the ignition coil. It has two metal points made up of tungsten and place against each other. These metal points have a circular flat face of about 3 mm diameter. Among the two metal points, one is fixed, and the other is movable. The fixed contact point is being earthed by mounting it on the base of the contact breaker assembly. The movable contact point is attached to the spring-loaded pivoted arm, which is electrically insulated. The pivoted arm generally has a heel or rounded part, cam follower, made up of some plastic material and attached in the middle of the arm. The heel is rest on the cam driven by the engine. Every time when the cam passes under heel, the contact points are forced apart and the circuit is broken. The pivoted arm is spring-loaded, and in the case when the points are not separated by the cams, it is held together by the spring force and closes the primary circuit. When the points are closed, the current flows through the primary circuit and it stops if open. 6. Capacitor. The capacitor used in the ignition system is similar to the electrical capacitor. The capacitor is an electrical device in which two metal plates are separated from each other through insulating materials, air. It is connected in parallel with the contact breaker. It prevents the contact points of the contact breaker from being damaged. If there is no condenser or capacitor used in the primary circuit, the high primary voltage caused by the collapse of the magnetic field around the primary winding would cause an arc across the breaker points. The arc produced would burn and destroy the points and would also prevent the rapid drop in primary current and magnetic field which is necessary for the generation of high secondary voltage. 7. Distributor. It is a device used in the battery ignition system to distribute the ignition pulses, surges, to the individual spark plug in a correct sequence and at the correct instant in time. There are two types of distributor. 1. Brush type. In the brush type distributor, it contains carbon brush carried by the rotor arm slides over the metallic segments embedded in the distributor cap. 2. Gap type. In this type of distributor the rotor arm passes very close to the segments of the distributor cap but does not touch it. It also contains some other auxiliary units too. In the lower part of the housing, it has a speed-sensitive device or governor whose main function is to advance the spark with the increase in the engine speed. Contact breaker assembly is present above this, which can be rotated to adjust the timing of the spark. In the upper part of the housing, a high-tension distributor is located. It also carries the vacuum ignition governor which serves to retard the spark as the load on the engine increases. Each metallic segments of the distributor is connected to each spark plug. As the rotor rotates, the contact point opens. This allows the high-tension current to pass to the spark plug through the segments to which the spark plug is connected. The sequence in which the spark plug is connected to the distributor cap depends upon the firing order of the engine. 8. Spark plug. The spark plug is used to generate sparks to ignite the air-fuel mixture in the combustion chamber. Each spark plug is connected to the distributor of the ignition system. Working of battery ignition system. In the battery ignition system, as the ignition switch is on, the current from the battery starts to flow through the primary circuit through ballast resistor, primary winding and contact breaker. The current flowing through the primary winding induces magnetic field around it. The more will be the current, the stronger will its magnetic field. As the contact breaker opens, the current through the primary winding collapse and this immediate collapse in the current induces a voltage of about 300 volts in the primary winding. This voltage induced in the winding charges the capacitor to the much greater voltage than the battery. As the capacitor charged, the current through the primary winding stops and the current starts to flow to the battery formed the capacitor. This reverses the direction of current and magnetic field in the primary winding. Due to the collapsing and reversing of the current and magnetic field, a very high voltage of about 15,000 to 30,000 V induced in the secondary winding. The high voltage current induced in the secondary winding is transferred to the distributor through a high-tension cable. The distributor has a rotor that rotates inside the distributor cap. The distributor cap has metallic segments embedded into it. As the rotor rotates, it presses and opens the contact breaker point. This allows the high-tension current to transfer to the spark plugs through the metallic segments. As the high-tension current reaches the spark plug, it produces spark in the engine cylinder for the combustion of the air-fuel mixture. Advantages: it provides a good spark at low engine speed. Low maintenance cost. Disadvantages: in the battery ignition system, the battery is necessary for the ignition. It becomes difficult to start the engine when the battery is discharged. Occupies large space. The efficiency of the system decreases as the engine speed increases. Since the breaker contact points are continuously subjected to mechanical as well as electrical wear which results in short maintenance intervals. If you liked this information then don't forget to like, subscribe. and share.